Hello. Oh, hi, friends. Welcome to lecture 4. This week we're going to be learning about abstractions, and you'll see quickly what that means. But before we dive into the content for today, just a couple of announcements. PA3 is due Wednesday at 11:59 p.m. The late deadline for submission is Saturday. And then for your assignments, remember to always double check your route spelling. If you check like in Postman that everything works and it's not passing the test cases, try to double check your route spelling. It could be like something really small, such as like user versus users. So make sure to double like every single letter in your route. And then always test in Postman before running the test script. I know it's like very tempting to just run the test script and see what's wrong, but yeah, it's better to test in Postman first because the errors that you get when you're testing that way is a lot more clear than the test script ones. So yeah. Also, your test script is like more likely to pass if you know everything is right. And then last but not least, when you're submitting the assignment, make sure to follow like the submission format and the assignment handout exactly. So that means to delete all your PyCache and DB files and just leave like basically whatever in the assignment handout, like the README, the actual code, and then I think that's it, but don't quote me on that. Check the assignment handout. But yeah, make sure to delete everything else, or else you will get things lost. Yeah, so that's all the logistical stuff. Does anyone have any questions about anything assignment lecture wise before we move on? Okay, cool. So we're just gonna go over a quick review of what we learned last time. So last time we learned that you have a server and you have a database. And so to actually interact with your database, you need to use something called SQL to communicate with the database. So you're going to have like different SQL commands such as insert, update, delete, select, and that sort of gets everything or does the database operations you need, and then it returns something back to you in the server. And then, yeah, so with the stuff in the database, you can create relationships. So if you have two different tables like users and posts, you can create a relationship between those two to associate whoever posted. And yeah, so a relationship is basically to relate data to other data in a structured manner, and then you can use foreign key columns, which basically references columns from another table to create those relationships. And then you have three main different types of relationships. You have one-to-one, one-to-many, and many-to-many. So a one-to-one is like the user and the profile. So let's say you wanted to maintain the statuses of like Discord statuses or whatever, and you had a user and profiles table. And I had two users, Kate and Shingo. I wanted to like create a profile for each of them. This is a one-to-one, and basically only one user can associate with one profile. So that foreign key in your SQL command, you have to like select it as integer unique. And so, yeah, so in here you can see that users like me is associated with user ID 10 in the profiles table. So profile, like the user ID in profiles is the foreign key. And if I try to add like another profile with the user ID 10, I get an error because that's not unique. And this is a one-to-one relationship. And then similarly, for Shingo, it can only associate with online where profiles like ID 30. So yeah, only one of each for this one. And then next for one-to-many, this one is different from one-to-one in that you can have like multiple like rows associated with, let's say, an album. So in this case, multiple songs can be associated with one album. So that foreign key in your songs table is not like no longer unique. So here we have this ID 10 and albums, and then it's associated with 2 songs in the songs table, and then ID 20 in the albums table is also associated with 2 songs in the songs table. So yeah, this one's different from one-to-many in that, I mean, one-to-one in that the album ID is not unique, so you can have multiple album IDs associated with the album table. Yeah, does that kind of make sense? One-to-one, one-to-many. Cool. And then lastly, we have many-to-many. So this one, you can have many students associated with many courses and many courses associated with many students. So to keep track of all the relationships that you have, we use an association table or like a join table. And in your join table, it works like you have like 2 columns, and then you have like a student ID, which is a foreign key. And you also have a course ID, which is also a foreign key. And so that's sort of how you keep track of the relationships between like each table. And you can have many of these, so it's also not unique here. Does that kind of make sense? Okay, cool. So yeah, here's just the graphic animation thing. So student ID 1 is associated with like 2 enrollments in the join table. So I'm in 1110 and CS 1998. And then yeah, I can use the course ID to sort of check the actual title in the courses table. And then similarly, I can do the same thing with like the courses table. So if I wanted to see all the students enrolled in 1110, I can like go into the join table and select all the rows associated with the course ID, and then get student IDs, and then see the net IDs of those students. So yeah, that's sort of how it works. And then if I had student 2 and I wanted to add another sort of enrollment, so let's say SN 685 decided to join CS 1998, I would just add a row to the join table, and yeah, that's how a many-to-many relationship works. So next we're going to move on to why we don't want to use raw SQL. So I know in PA1 we used a dictionary, and then that was bad because you couldn't sort of maintain data each time you restarted the server. So in a database, you could like have consistent data throughout each time you like ended the server or like started it again. And so with SQL, you probably noticed this when you were doing your assignment, but it was sort of very hard to read. So abstraction sort of takes away from that. And so yeah, this is sort of what I was talking about. Some pain points about SQL were that it was just very hard to read. There was just like lots of words. And it's also very like susceptible to vulnerabilities. And so we'll talk about what like SQL injections are later, but it's very easy to like manipulate. So we have like a login, for example, you could easily manipulate SQL commands to sort of mess it up. And then also it doesn't really handle exceptions very well. So let's say we have this like really long query. It's just really hard to read. Like if I looked at it, I probably wouldn't be able to tell what it's doing. I think it's selecting like the name language from a countries table with like the max surface area and then something else. It's just very hard to read, and you probably have to spend a really long time trying to figure out what this is doing, and this is really sad for, let's say you're working on a project and yeah, you have to read this. So it's just not very easy to read. And then there's also vulnerabilities. So yeah, a SQL injection is just when you sort of specially craft an input to trick the SQL semantics. And so you basically can allow a database to be accessed by anyone. So it could be a hacker, and they could really easily create SQL commands and mess up your code. So yeah, you can just query unauthorized data and corrupt or delete existing data. So for example, if I had a login and I was a hacker and I wanted to hack this login system, I could easily just take like all the users with some email and some password and get get the information I need, even though I'm not actually this user. And so let's say, yeah, I can just basically insert some random data and just get all the rows and stuff that I need. And I'm not actually this person, so it's really bad. And you can just keep on doing different sorts of combinations where you sort of try to get all these users' information. And yeah, there's just a lot of different things you can do. And to fix all that, we do what's called object relational mapping, or an ORM for short. And so what is an ORM? So an ORM is basically taking an object and abstracting it. So instead of doing SQL commands directly, we can sort of query and manipulate it as objects. And then we still, everything sort of is, like, we still have a database in SQL, but it's just on our side, it's really easy to deal with. And instead of like dealing with rows directly, we sort of do it as instances of an object. So for example, in SQL, if I wanted to create a table, I would just create a table of users and then all my columns. But in ORM, we sort of abstract it so that you have like a class of users, and each sort of attribute is just a column. So it looks a lot nicer than SQL, and it's a lot easier to deal with. So in this class, we use SQLAlchemy as our ORM. And so this is just a popular ORM for Python, and it comes with a lot of built-in query patterns. So it selects stuff for you, and it integrates very seamlessly with Flask. And so SQLAlchemy is just like, it works differently from Flask. Flask is like what you use to interact with like a client. It sort of like defines the routes for you, but SQL is like, where SQLAlchemy is sort of the tool you use to interact with your SQL database. And so it's different, but they work very well together. And so the benefits of using ORM is it's very readable, and it's like a lot more human friendly, and it's not as messy as SQL. There's not as much going on with all the keywords and stuff. And your database and application basically use the same logic. And you can also, like, it's also compatible with other databases. So for example, let's say I have this ORM and I wanted to use it with like, not just SQL I want to use it with like Postgres, because an ORM is sort of like an abstraction of all like your information in the tables. You can sort of apply it to different databases. So it just makes scaling also a lot easier. And then also it's very secure against SQL vulnerabilities like injections, because it's more abstract. Does that kind of make sense why ORMs are good? Okay, cool. And as with anything, there's also drawbacks. So it is a bit slower for more complex queries, and it increases a bit of application code to write more lines because it's both SQL and abstraction. And then also, you don't really get to learn as much SQL as you would when you're using the ORM because you're not really, I guess, interacting with the keywords and like writing SQL code. And then there's also a potential for misuse because it's too abstract. But I wasn't really worried about any of these in this class, but yeah. And then last but not least, I wanted to dive into the difference between your app.py versus your db.py. So your app.py sort of connects the server to your client. So in your app.py, it's where you define your routes and your responses, and it sort of handles all your logic and operations. So for example, let's say in PA2, you have to like sort of spend money, and an app.py would be a good place to sort of handle like how much money the sender has to like how much your balance would update in your sender and how much it would update for your receiver. And your db.py is where you actually connect your server to your database. So it defines your tables and columns, and this is where you insert, update, retrieve, and delete information. And so this is just a nice graphic sort of putting this all together. So in the first lecture, we talked about the client server model and how your server is where you like return, it's where you send a request and then you get a response back. So yeah, so your client sends a request to the server, and then your server a route is triggered, and then you do a data operation. But within this data operation, it's where you actually interact with your database. So yeah, so when you're doing your data operation, you can interact with your database to get the data you need to actually do those operations. And then with the data, you do the operation you need and then return a response back to your client. So that's how sort of everything comes together in the end. Oh, yeah, your response is returned. And yeah, that's basically everything in lecture today. Does anyone have any questions about ORMs or app.py versus db.py? Okay, cool. So we're going to move on to the demo.
Okay, before we get started with demo, I want you guys to all pat yourselves on the back for getting through all this. Today will be our last demo and last lecture for actually building a backend. Starting next lecture, or starting next week rather, we'll be learning about how to deploy our backend and how we'll make it accessible for other users to use. So yeah, let's take a moment to just appreciate how far we've come so far. You know, now we can communicate from our laptops, from our phones, to these servers that we've built and store information as desired, right? So, little congratulations. Okay, let's get started with the last lecture for building our backend. So, sorry, last demo. The first thing that's really annoying, and I apologize, this is really annoying, is that our textbook is in Gitbook and it's really jank. And so if I actually open Abstractions here, like this week's page, you can see that there's only 4 things there, but if I refresh it, like the pre-class to-do shows up. So just like, this is because some of the information that's on Gitbook is cached onto your computer. So if you could go ahead right now and go to Gitbook, go to refresh it first, and then go to the pre-class to-dos and download the starter code. It should look like what I'm about to use next. So I'll give everyone a minute to do that. Okay. Okay. So hopefully we're all good. So I'm going to get started for a demo. So as usual, let's cd to our folder, right? And we have to create a virtual environment. As usual, we want to be creating a virtual environment outside of the source folder because the source folder just contains our code. Let's do that. Can everyone see this, by the way? Is it too small? Is it too... No, we're good? Bigger? Okay. That's going to mess up with my ZSH. Okay. All right, so now we have a virtual environment. Let's activate it. And let's cd into our source folder. And let's install our requirements.txt. So if you've, you should install the virtual environments every time. But for whatever reason, if you haven't been doing this, this week's requirement.txt is going to be slightly different than the past weeks because we're using our ORM called SQLAlchemy. So make sure you do this. So let's go to our code. Be out of this and go to our code. And that is very small, so let me make that bigger. So this is what the starter code should look like. If this is not what you see, please go re-download from our textbook. Oh, this isn't actually the DB file for this this demo. I'm just having it here to show off what we did last time. Actually, let me just like hide this for now. Okay. All right, cool. Bigger? No, I can't see anything. Is this good with everyone? Show of hands if people can't see it. Can't see it? Can't. Okay. Let me get one bigger. Is good? Okay. All right, so let's go over just quickly some setup stuff. As a lot of us have been doing for our past PAs and demos, we have to import request. Oops, request, sorry, singular request. And yeah, so let's just quickly go over what all of this is. Close the what? This? Oh, this? Okay. Okay. So again, like Kate mentioned in lecture, an ORM is basically a translation between SQL code to Python code, right? It abstracts the SQL out of it and makes it into Python code, which a lot of us are, one, more familiar with, and two, is very nice to type in VS Code because we have syntax highlighting, right? So yeah, that's what an ORM is. So let's go over what all of these are doing. So db_file name is just the name of our file. We're creating our app, our Flask app as usual. These things, you can look up what each of these do by just typing in, go to your browser and type in SQLAlchemy configuration. And you can go here and look at them in detail if you really want to. But I'll quickly go over what each of these are doing. So the database URI is telling the SQLAlchemy library, hey, this is the type of SQL library I want to be using, right? SQLite 3, and what the file name of that SQLite file should be. So in our case, it would be todo.db because we're continuing on with our demo from previous lectures. This thing, just don't worry about it, just have it. If you really wanted to look it up, but you can, but yeah. And this thing is really cool, SQLAlchemy echo, because what it does is it tells us when we run our app what SQL code is actually running. So again, we're going to be abstracting away the SQL code and typing in Python code. But if you really are curious about what SQL code is running under the hood, then you can put this to true. But it can clutter up your terminal quite a lot. So if you're just like not curious anymore, you can just set this to false, and it will like not print as much information out. So that's what these things do. These are just like some syntax stuff for initializing the app, and you won't have to worry about it too much. But create all creates all our tables, which we'll define in a second. So that's what that does. Okay, and for those of you who may not have understood what these do from previous lectures or from previous demo, it takes in two parameters. It takes in data and code, and kind of just dumps it into this function. However, you can see that code actually has an equal sign and a value after it. This is a default value. So if you don't specify the code, it kind of just uses 200 as a default value for you. So I have an example open right here. Okay, ignore all this stuff. I was testing. We have a function that says print code, and the first parameter is optional, and we have a value of 200, and it just prints the code that we pass in. So if you do print, and I don't pass in this optional parameter, it'll just, okay, that, well, okay, you can see up here, oh wait, it's because I typed, okay, that's my bad. If I call the function, and I don't pass in anything, that optional parameter will just take in this default value and print that code. But obviously, if I do specify it, then it'll override it and use that value. So that's what this success response and failure response thing is doing. It takes in a data and it takes in a message, because a lot of our JSON.dumps line is always going to look like this. But our code, we can specify if we'd like to. But in the case that it's the usual 200 or 404, in case something's not found, then it'll just use this default value. Does that make sense? Cool. I'm aware not all of you have taken 1110, so I'm just quickly going over that. Now, let's move on to our db.py. And start some stuff here. Cool. So, how is SQLAlchemy going to abstract SQL code to Python code? In SQLAlchemy, instead of like in SQL where you have tables and you have entries in a table, you have classes and objects, like we're all familiar with. So, for instance, if you wanted to make a task table, we would make a task class and make objects of that class, right? So this is like a translation between SQL and Python code. So the first thing we'll make is the class table. Let's do class and call it tasks. Again, this is Python code that we're typing, so it should be in Python syntax. So let's say we have like tasks to do, right? You wouldn't do task to do because that's in snake case. We would do it in as such for Python class names. So let's call it tasks. And we'll specify that this is a db.model. So what this means is that this task class we're making is a model. It's a blueprint of the objects we're going to be making. This is just telling SQLAlchemy, hey, this task thing is a model. It's a blueprint for all of the entries that we're going to be having. Next, we can define our table name by doing __ table name equals, and then the name of the table. So this would be in SQL syntax, which is in all lowercase. And now we can go ahead and start defining what all of our columns are. So we have, right, let's actually compare this with our previous db.py. So this is from demo 3, I believe. We have a task table, and we have an ID, a description, and a done field, right? So this should look familiar to you guys. So let's go ahead and create that ID, right? And oops, it just auto-filled for me. Description and a done field. So what goes in one of each of these? Well, as you probably, well, you're seeing here, you can specify a column in SQLAlchemy by doing db.column. You can specify the type of the data that's going to be going into these, right? So that's integer. So that's db.integer. We can specify that it's a primary key by doing, primary key equals true, as it says right here. Looks like that. And finally, okay, it doesn't have auto increment, but we should have that. So we have auto increment equals true as well. So let me do that. So again, the great thing about ORMs is that since you have syntax highlighting, you can see here that it has syntax errors right here. Or if I call this like, let's say I don't know, colon. It should, okay, maybe it doesn't. Maybe my SQLAlchemy is broken. But essentially, it's much more obvious if you make a mistake here, as opposed to if you make a mistake in SQL, raw SQL. So if I have a comma here, right, it's not going to tell me anything. And maybe I'll like spend hours debugging this comma. That's a great thing about ORMs. So let's continue on and define these columns. So again, a description is a text. A fantastic thing about SQLAlchemy is that we will no longer have to call these things text, but rather strings, as we're all familiar with. So we'll call this db.string. And this cannot be null, as per previous demo. So we'll do nullable equals false. And then let's do the same thing with done. So db.column, db. Okay, and another great thing about ORMs, oh my God, I'm selling this so much, is that we actually have Boolean support. And so basically, like Kate said, an ORM, once you specify what kind of SQL library you're using, say SQLite 3, it knows that SQLite 3 stores Booleans as zeros and ones under the hood. And when you specify that it's a Boolean, it'll handle everything of like converting zeros to like false and ones to true and all that for you, which is fantastic. So let's do that. Now, we want to be able to initialize an instance of this class. So to do that, this may be familiar to you who have taken Python 11.10, but we have an init function where we have self. And we'll be using this crazy thing called a kwargs, which stands for keyword arguments. Now, another quick demo on what kwargs is. So kwargs, you can basically pass in whatever you want. And you can already see I was practicing earlier here, SMH, ZSH. But let's say this demo function takes in a kwargs argument, and it just prints it. If you do a demo and then pass in like Shungo, or no, oh my God, what is going on? Demo name equals Shungo, and age equals 20. I'm 20 now. Oh my God, I'm old. You'll see that whatever's printed is a dictionary of the key being the argument name and the value being the value that's passed into that argument name. So that's amazing, because now if we go here, we can do self.description equals kwargs.get, again, because kwargs is a dictionary, right? It's a dictionary. So this should look familiar to you guys who did PA1. Kwargs.get, and then our description. And then we can even specify a default value when we do the .get function. So we can specify that if we don't specify a description, just assume it's an empty string. And then self.done, same thing here. Kwargs.get done, and our default value can be false. So the great thing about this is that instead of having to do, description and done every single time, we can just have like a kwargs kind of just take in all the arguments that are given to me and convert it into what's necessary. That'll be our init function. Object, all right, self entry in our table. And then let's make so the issue with this code right now is that it's a Python object, and we have to somehow convert this into a JSON format. And as we all learned, JSON.dumps can take in a list, it can take in a dictionary, right? It can take in a lot of things, but it can't take in a Python dictionary. So we have to make, a Python object. So we have to make a function that will convert our objects to dictionaries. And the process of doing that is called serialization. So let's make a serialize function. And let's just return the dictionary. Oops. And we'll have ID is self.id. We'll have description is self.description. Oh my. And then we'll have done is self.done. Cool. we good so far? Does make sense? Okay. Now, from demo 3, we had another table. We had another table called Subtask. So let's make that Subtask class. Class, wait, let me realize object. I'm going to call it object. Class subtasks, and it's another model. And as you can see here, a lot of it is going to be the same except for task ID. So I'm going to use the best tool in programming called copy and pasting, and just do that. Are we good with this, or am I going to be scolded? Are we good? Cool. Okay. So we have an ID, we have a description, and we have a done. That's identical to our task. Next, let's create the task ID field that we very much needed from back here. And this is another column, right? It's a foreign key column. The task ID is always going to be an integer, so that's the same here. No, it is not a primary key. So the way we specify that it's a foreign key in SQLAlchemy is by doing db.foreign foreign key. Did I spell that right? Okay, I spelled that right. Foreign key, and then in quotes. And this is going to be very similar to what we did with SQL right here. We have the name of the table, and for God knows why, a dot and then the field, not parentheses like in SQL. And then we have to set that nullable to also be false, because we cannot have a subtask just be laying there. Let's do the same things we did up here. So init and serialize. So we have an init function, and we pass in self, and we pass in the keyword arguments, and do the same thing from back here. Also, if you're wondering, having triple quotes here and just having the one-liner comment, basically equivalent. As long as you're commenting your code and we understand what you're doing, feel free to use whichever one you're more comfortable with. Okay, init function. We have our description, we have our done, and we have self.task ID is equal to kwargs.get task ID. Now, the reason why we don't specify a default value for here is because, well, we don't have a default value, right? There's no default task to associate a subtask to. So if this constraint is failed, right? If this task ID thing isn't actually passed in, then you can just assume that the subtask creation was failed. So it's fine if it crashes when you don't pass in a task ID, because that's the front end's fault. Nice. We love to blame front end, even though we break everything. Finally, I'm going to close this because that's basically all the information we needed from the demo 3. We'll have to have a serialize function as well, so let's do that. Self serialize a subject, and let's do return. ID is self.id. We have description is self.description. Done is self.done, and we have task ID equals self.path ID. Beautiful. Okay. Cool. So now that we have these two models, let's go back to app.py and start implementing the functions for these two models. Go back to app.py. Does anyone need to copy db.py? Should I leave it up? Anyone? Okay, I'll leave it up. Hopefully you can kind of assume what goes in here. Move this up here. All right, so we have our success response methods and failure response methods. So in case we have a successful response, we can just call this function and pass in the data. And we have a failure response, we can just pass in the message, and it'll return the expected error. So let's define this one, get tasks. Here, we can do return success response. And we have to make a dictionary, just like last time. We have our tasks, and we have to get the tasks that are in our tasks table. So the way we do that is by doing, actually, one thing we can do is do a task and do for task in. Oh, okay, sorry. One thing I forgot to do. Since we have classes here, we have to actually be able to call these functions. And to be able to call these functions, you have to import them from up here. So let's do from db import tasks and from db import subtasks. All right, that's a few classes we made. We're good? Let's go in here. And now we have a class called tasks, and we can use SQLAlchemy methods on it. So we can, the way we select star from the task table in SQLAlchemy is by doing .query all. So this gets all the tasks in our task table, and this is a for loop, right? So we're looping through every single task in our task table, and we're appending it to the tasks list that we have up here. So task dot serialize. And then we can pass in this tasks list. So now we have a list of tasks, right? We initialize an empty list, we query through each task in our list, and then we append it to our list. We append the serialized version to our list, right? Because we can't have objects being returned as JSON formats. And then we return it as a successful response. All right. Does this make sense so far? Amazing. So let's go ahead and actually just run this. Let's get rid of all that. Python 3 app.py. And you can see all the SQL queries being done to create these tables. Kind of cool. We don't have to worry about it too much. So let's go to Postman, and let me zoom in on this as well. Oops, that's too big. Okay, and go to our workspace. No, you saw nothing. There's no attendance Kahoot. Let's call this demo 4. Oops, demo 4. And create a new request, and let's call it get all tasks. Oh. To send this request, it should successfully give us the list of tasks. Okay, so that's going to be it for demo. We're going to cover how to insert, how to update, delete, all that stuff next time. But so far, we've made 2 models, right? And we can query from them. So is everyone good so far? Do we have any questions before we move on to Kahoot? Yeah. Okay, why don't you go help? Okay. Let's wait for a bit and then start the Kahoot.